Welcome to the show today. This is going to be an interesting one. First off, this is actually our first episode that we're recording in two separate locations. So we're going to see how that goes, get the editing for that, and hopefully it sounds good for all of our listeners out there. We're going to start off by going into the history of ethology. So we're going to be talking about ethology, talking about Nazis, talking about deep learning technology, lots of different stuff. So stay tuned and listen to this episode if you want to learn about any of that. I'm Hunter.
And I'm Luke, and you're listening to Epistem, a show where we explore papers in STEM fields and let you know what they're all about. When we first started looking into this paper, I knew that there had to be a whole field of science and research devoted just specifically to researching animals, and it probably has a very long history because as long as humans have been around, we've had a very intimate relationship with animals, right? Whether for food or animals to avoid or animals to hunt. So there's definitely a lot out there that we could benefit from studying animals, and again, it's probably been around for a very long time. So this field of studying animals is called ethology. It's just the study of animal behavior, but specifically when you're talking about ethology, it's about studying behavior of animals in their natural habitat for the sake of understanding their behavior as an evolutionary trait. So it's not so much studying them in a lab, but more so studying how they behave naturally.
And as we know from this study and other studies we've looked at, it's really hard to get an in vivo environment, especially when studying animals, because you have to really apply a lot of different factors and a lot of different environmental, changes into the way you make the environment that you do the testing.
Yeah, and you also want it to be ethical too, right? So if you're doing in vivo testing, you want to minimize the harm that's going to be done to the animal, if any. So there's a lot more regulation as well, for good reason. So one of the people who's considered a founder of modern ethology, his name is Conrad Lorenz. He's an Austrian. So he did a lot of research on the idea of imprinting. So this is kind of the idea, if you've ever heard of how baby ducklings will imprint on the first animal they see when they're born. Usually, hopefully, it's the mama duck, and then they'll follow that animal around. That's a common example of the idea of imprinting. He's not the person who discovered imprinting, because that's been around for hundreds, if not thousands of years. But he's known for his work with imprinting as an instinctive bond. So again, kind of focusing on that evolutionary portion of it. Here's a fun fact about Conrad. His research was halted whenever he was recruited into the German army in World War II. So they knew that he studied animals and animal behavior. So instead of making him a motorcycle mechanic, which is what he wanted to do, they had him study half German, half Polish people to test whether they were benefited from being part German. It sounds pretty crazy, but the Nazis believed that pure German blood gave them genetic advantages. So that's kind of what he was forced to do when he was in the German army. Later after the war, he said he regretted being part of it, but it's interesting because a lot of his involvement with the projects that he worked on is still pretty unknown. I would imagine he's probably not super proud of it. I know I wouldn't be if I were him. But he didn't do that for too long, because soon after joining the German army, he was captured by Soviets and spent 4 years as a German prisoner of war with the Soviets. So anyways, I thought that was an interesting bit of history regarding ethology.
Yeah, that's really interesting stuff. I don't know as much about Lorenz, but I have heard that he's did a lot of studies on animals themselves, but he also did do some psychology studies, didn't he?
Yes. He did some of his psychology stuff, I believe, after he got out of the military.
Okay. Gotcha. Well, that's really cool. Well, as is with regular Curiosities, something I found really interesting with this past podcast and this past research article that we were looking at was deep learning technology. I want to go a little more in depth into the deep learning, and also just about how it works. So I'm going to explain a little bit and go through that. Let's start by talking about machine learning in general. So using machine learning, you use an algorithm, which is named a machine learning algorithm. Think about that. This involves giving a program different examples of what it will be analyzing and telling it what the outcome or judgment should be given to to that specific example. So I guess a good example of this, unrelated to machinery, is teaching a kid right from wrong. If you possibly show a kid a picture of a busy road and tell them it's bad to cross then, and show them a picture of a good road or a non-busy road and tell them that is a good time to cross. That's similar to how machine learning starts. You're showing different examples of code to a machine and telling it what the outcome should be, whether it be a right or wrong answer, or whether it be a lot of different things depending on what your code is actually meant to do. You're going to have different choices, and you're going to show the program that code and tell it what the outcome should be. So regular machine learning is great for data sets and things that can be taught with computations. However, you need to dig deeper if you're analyzing images, sounds, or other data that isn't structured text. To counter this, deep learning algorithms create layers that are called neural networks, which are named after the brain's neural networks. Each layer finds specific features in an image, a sound, or whatever it's comparing, and compares them to the correct sample that it's trained to. This has actually been around for many years. It's been studied and theorized for over 60 years now, actually. But until recently, it hasn't been able to be actually implemented due to data and computational pricing and availability that is needed for deep learning, because you need a lot of data and you need a lot of machinery that's actually high functioning and can handle a lot going on at the same time for it to actually work out. I can't talk about the specifics of this example, but I have used machine learning in some work that I've done where I was actually teaching a vision system what was right and what was wrong for identifying if it was if the product that I was looking at was correctly placed or not. So with this, you go through a training demonstration or training period where you show a bunch of images or a bunch of products to the machine, in my case, to a camera vision system, and tell it if it's good or not good, and to what percent that, what percent error or what percent...
Is it kind of like you're giving it a grade?
Yeah, you're essentially giving it a grade. You're like telling it that this is 70% correct, or this one is 100% correct, based on different dimensioning and whatever you're looking at, whether it be dimensions, whether it be different contours, or something about the piece you're looking at. But yeah, you're telling it exactly what it should be looking at and how closely that relates to it. And it starts learning from there and building upon that to be able to differentiate or compare what it will be looking at to the good images you have trained it for.
Yeah, so there are a lot of computational ways to deal with large amounts of data, especially when you're talking about behavior or teaching a computer situations where it requires a lot of data. And in the episode, we talked about classification techniques, where the software would parse out features, just choose pieces of data that maybe represented a pose or a movement of some kind. And this technique is used in a lot of different applications. A similar technique is used in vocal recognition, like Alexa or Siri. I have to wait because Alexa just responded. So instead of breaking up movement data into pose estimation, you're basically breaking up sound data into words or sentences. I don't know if you've ever had to do this when you get a new phone, but I know I have an iPhone, and whenever you set up your iPhone for the first time, you train Siri by saying some phrases that she asks you to say. And essentially, you're just teaching Siri how you break up your sentences and your words. And then you also have things like email services that use something like this, where they are trying to sort spam from not spam. So usually it does a pretty okay job at it on its own, but sometimes it sends good emails to spam and you have to tell it, no, this is a good email. And sometimes it sends spam to your regular email and you have to say, no, this is spam. And you're basically training it to say, or you're training it to identify what a spam email looks like. It learns the common features of a spam email.
Interesting enough that you brought up the software that Alexa and Siri use, because they also use the same deep learning technology for translation software. So translation software analyzes your voice and comprehends how you speak, and then it uses that to convert that speech to text. And then that text is then input into a translation software or input into wherever you're, if you're trying to search for something with your Google Home or find a song on like an Amazon Echo or something similar. That's actually how it works. It's a conversion of sorts, and that's where deep learning comes in for that conversion itself, and actually learning how your voice differentiates and how your voice changes with different background noises. Another cool thing that I found deep learning technology can be used for is actually cancer detection. Researchers were able to give programs tens of thousands of mammogram scans, and in that testing, they were able to detect cancer very accurately due to finding common characteristics in mammograms that contain cancer compared to those that didn't. And this could possibly reach out to cancer detection in other fields or in other different kinds of cancer in the future, depending on the research that's put towards it and how much deep learning training is put towards it.
That's cool because it illustrates the advantage of having things like machine learning and deep learning like this, because you can have a person look over thousands of mammograms, right? And they may not notice that there's some little trend, but a computer remembers everything it sees, right? It's good at identifying trends through tons of data. So it's a cool application.
Yeah, it really is. But on the flip side, I'll play devil's advocate here. There are some problems with deep learning, and related to that, with you talking about like someone looking over mammograms all the time, there are things that possibly a deep learning technology, as of now, would not be able to detect, and that's because at times the algorithm can actually get too complex, and essentially the learning just goes down in a rabbit hole where sometimes the researchers that are actually making the programs, making the machinery, don't know what's happening in the program because it's just trying to learn from these little obscure things that are happening within a picture, within a whatever it's looking at, and this can actually lead to misdetection, or in the case of that cancer detection, or possibly a mistranslation in that software, or so on and so forth, with a lot of different deep learning technology uses.
So it can be too sensitive, or it can pay attention to the wrong parts of things.
Exactly. It might start paying attention to the wrong colors or the wrong shapes that it shouldn't be. But once it starts learning that, it might just be compounding on its learning, because that's how it works. It keeps on building like a pyramid. It's going to continue on building upon its base, and it could be building in the wrong direction.
Yeah, I'm envisioning like if I showed a computer a picture of a coffee mug and I was like, this is a coffee mug. And I showed it a bunch of pictures of a coffee mug, and each picture I showed it had a table in the background that it was sitting on. But then I showed a picture of a coffee mug, that I'm just holding, and there's just nothing but maybe grass in the background. And it freaks out because this whole time it thought that when I was showing it pictures of coffee mugs, I was really showing it what a table was and calling it a coffee mug,
Yeah, exactly. And that's another one of the problems, is that they require a lot of training as to what is a good versus a bad picture or whatever you're looking at, or just differentiating features. Like if you're trying to train it, as you said, for the coffee mug example, you're going to need to train it with a lot of different backgrounds, a lot of different mugs, and a lot of different contours and just variation. And that training really takes a lot of time. And it takes away from someone, a researcher, or whoever might be doing it, takes away from value-added time that they have. Yeah. There also are, within any coding system that is AI or learning from itself, I guess, is there's going to be an inherent bias within the system, whether it be from the training or whether it be from adding on to its own depth, like its own learning algorithm. Somewhere in there's going to be some kind of bias within the system, whether it be good or bad, is up to the system and up to what you're using it for. But it's very hard to create a training method that doesn't have that set bias in place.
All right, we're going to split for a quick ad, and then when we get back, we will hear from someone involved in animal research before closing out. So we'll see you after the break. So I've got my friend here, a friend of both of us actually. Her name's Ashley. She's done some research involving studying animals, so I'll just let her explain exactly what she does. She graciously let me call her while she was on a road trip, so I'm going to apologize for some of the road noise you might hear in the background.
Hi everybody, my name is Ashley Ring and I'm a senior studying animal sciences at Purdue University right now. I actually work in a poultry nutrition research lab, but the lab adjacent to mine that I also co-work in is a behavior research lab. So I participate in both poultry nutrition and behavior research. And I've also got a minor in entomology, so I've looked a lot at insect behavior as well.
At least as far as you're concerned, why study animals or insects in the first place? What is there to be gained?
Yeah, I mean, in reality, there are thousands of reasons I could list. There are extremely beneficial reasons to study both animals and insects. One of the most important things for us in studying animal behavior is to look at production. Everybody wants to know what is the way they can make their animals produce more efficiently with less money. So usually what they're doing is changing something in the animal's environment and looking at how that affects their behavior. For every different species, we know the certain behaviors that represent, just from studying over time, more of a positive result versus a negative result. And we can measure the productivity along with that. For example, in my lab, one thing that we did was change the different floor matting in the different cages for the hens to see, what their behaviors would be. So there's tons of different behaviors. You would laugh, we sit there and record scratching, pecking, grooming, feather dusting, all these different things. And we know which of those behaviors are correlated with good or bad feelings, essentially, for the chicken. Then, like I said, we measure how many eggs are coming out along with that. And so we can use the behavior to really understand better how to be more efficient. And that's really important because in all animal research and use of animals, we want to be as efficient as we can be and not, use any more animals than we have to. So I think that's definitely one of the most important reasons to study animal behavior.
So what she talks about next is really cool because we shift from looking at animal behavior to looking at insect behavior, which if you think that it's difficult to find a good reason to study animals, then you probably are also thinking, what the heck are insects going to tell us that's useful? But this is really cool because if you know anything about ants, they have all these different jobs that are assigned to them from the queen. But a lot of ants will go out and search for food, and they will leave a scent trail from the colony to the food so that other ants can follow that scent trail and just keep taking little chunks off of the food and bringing it back to the colony until it's all gone. But what they find is that they have some really interesting behavior regardless of these scent trails that defines their movement.
What's really interesting is the way that they move is completely randomized. They can produce these scent trails, but overall their movements are completely random. Whether or not they run into that scent trail is completely by chance. They're just kind of moving about randomly until they come up on a scent trail. And so they've actually started to use the random movement of ants to study how we can better program self-driving cars.
Yeah, ants helping us make self-driving cars was not what I was expecting.
Yeah, self-driving cars have the issue of not being able to understand what random events might occur. So that's the biggest challenge they're having with programming self-driving cars is, you can't predict any infinite amount of random events that might occur. But they're being able to do that better by studying the ants and actually recording them with cameras to code in all the different random events that might occur. So they're getting closer and closer to making self-driving cars really safe, even using some data from insect behavior.
Well, there you have it, folks. Thanks for tuning into this episode. I hope you enjoyed it. Hope you enjoyed a little bit different of a format. We threw in a little bit of history, and that's a little bit abnormal, but I thought it was fun. I thought it was interesting. Let us know what you think. If you do have feedback, feel free to reach out to us on Instagram. Our Instagram is epi.stem. That's epi.stem.
Yeah, if you want to hit us up with any questions on our email, if that's a better format, you can hit us up at epistem.pod@gmail.com.
And if you're feeling super duper generous, hit us up on our Patreon. That's patreon.com/epistem.
Much appreciated. And keep on learning.
Mammogram scam.